In this video, I want to talk about the design document requirement and also go through an example of my own design document and one that we will use throughout this semester. A couple of notes to start us off with. By this point, you should have a group selected. If you don't yet, I recommend you very quickly go to the discussion board and then group project ideas and team sign up. Next, what you'll want to do is this design document assignment, which we'll take a look at here. So we'll go through all of these points in detail in this video. But one pretext I want to keep in mind is the Manifesto for Agile Software Development. This is kind of an infamous quote, or I don't know if you'd say quote, but reference, something we reference a lot in our field. And it's signed by several individuals who contributed to this Agile manifest. Prior to Agile, we had kind of a more industrial waterfall approach and very long time before you'd actually see the fruits of your labor. So with Agile development, we're looking at doing things a lot quicker and responding to change faster. In other words, embracing responding to change instead of resisting it. So let's take a look at these 4 lines here. We value individuals and interactions over processes and tools. We value working software over comprehensive documentation. We value customer collaboration over contract negotiation, and we value responding to change over following a plan. So I think the last phrase here is also very important. While there is value on the things on the right, we value the things on the left more. So it's not saying no documentation, no contract negotiation, no processes and tools. It's just saying let's work together and let's collaborate, and we value that more than the things on the right. We need the things on the right, but we value the things on the left more. So with that being said, we don't need a document that is tremendously verbose and has a whole bunch of legalese and a whole bunch of invalid text. We really want to focus on a document that's going to deliver good value to us. And how do we define good value? Well, for me, I want to take a look at your design document early in the semester so that I can make sure you're on the right path. So that's really the value of the design document to me. I want to take a look and say, this is something that's achievable, that's doable with the technology stack that we have, or this is not something achievable or doable, or some combination of the two where I think it's achievable if you change this. So that's what I'm looking at. I can tell you, in having taught this class and several similar classes over many semesters, there are some hang-ups that I see relatively frequently. Here's an example from a mobile development class I taught previously. This is a storyboard that a student group submitted, and I don't recall the group or who the students were. But this is a mobile app, and take a look at this. Look at all of the different screens that you have. This is a case where I would save the group's time by saying, don't bother with this many screens. Consolidate down to a smaller group of screens because it's going to take you less time to develop, and it's going to be a better experience for your user. For example, scratch the main page. Don't have a main menu, don't have a splash screen, and try to avoid a login screen until you actually need to know who the user is. Reason being, it's one additional click for the user, and additionally, a main menu tends to put everything at the same priority, where we really want to make it easy for the user to do the things that the user wants to do 80% of the time. So instead of a main menu, what we typically recommend is jump right into the thing that the user wants to do, but then offer the user a choice to go to other features from that main feature. So scrap the main menu. Going through this, especially for a mobile app, I would recommend that the group cut from, say, the roughly 10 or so screens that you see here, down to 1 or 2. So that's what I'm looking for in the design doc as a way to go through and help you make effective use of your time. One other thing that I'll typically recommend in a design document. We have groups of 3. Of these 3 people, one should be essentially a Scrum Master, a product owner, GitHub administrator, manage the Scrummy board. So one's handling a lot of those tasks, and that's quite a big job, especially managing the GitHub operations. Then we should have one person focusing on the user interface, so both the look and feel and also handling button clicks and things like that. And then we should have one other person doing persistence work and business logic. So the trick is that we have to make sure that these people can operate in parallel, not in serial. And that's a big focus of this design document, is I want to make sure that we can operate in parallel, not in serial. Reason being, let's say that the person who signed up to do persistence and business logic has a busy semester and isn't making his or her commitments. If we're in serial, then everybody else has to wait on that person. If we're in parallel, we can continue to work separately while we're waiting for this other person. So that's what I'm looking for in the design document. So let's take a quick look at the 8 major sections. So we want an introduction, a storyboard, some functional requirements in this format. As a user, I want a certain feature so that I can do something. And then we want several examples in given when then syntax for each of these requirements. After that, we want a class diagram. I'm going to use Argo UML for mine, and a description of the classes on those diagrams. A Scrummy link, and that will be to our Scrum board, and then the Scrum roles and who will fill those roles, and finally a GitHub project link. So some of these concepts I'll cover directly in this video. Others I will have some additional reading videos where if you've never used Argo UML before, I have a video from a separate class. It's agnostic to that class, so it's really just about using Argo UML and how to put it together. So I'll have that one as an optional video that you can watch. Also, I do have a video that I would like you to watch on GitHub and how to associate GitHub with your account, with your development environment. So a couple other videos that we'll call out to. First of all, though, let's look at the draft design document I've put together. So to kind of speed up the video a little bit, I started drafting this design document. As you see right now, it's kind of monotone, all the same font. So what I'm going to do is I'm going to say, okay, let's give it a title, My Plant Diary by plantplaces.com. And then design document, we could put some kind of formatting there, and my name. Probably want to put a date in here as well. So under that introduction, let's give this a heading because this is one of the major 8 components that we need in this design document. So introduction was one, and then storyboard was another one of the major headings. Let's go ahead and make that a heading 1. We'll talk about each of these in detail in just a moment. Functional requirements, another one of our 8 major components, and then our given when then syntax we'll take a look at in just a moment. Class diagram, another one of our big components. And then class diagram description, that was another one of our big 8. The scrummy.com link. You see some of this I've filled out to help us along in this video. Other parts I've saved and we'll do together in this video. Roles and GitHub project link. So each of these will go ahead and make a top level heading so we can kind of see some organization. Okay, so to start with the introduction, for this 2 paragraphs, 3 paragraphs, that's fine. Just something that's basically kind of like an app store description for your application. So my introduction. My Plant Diary allows homeowners to maintain records on plants in their yard. They can upload photos and add notes to a plant at any time, meaning at the time of planting or after planting. Plant data, including sustainability and edibility, like can you eat it, are sourced from plantplaces.com master data. So in this case, we're considering plantplaces.com to be an external source of data, a JSON feed, which is going to give us our feed of eligible plants for a yard landscape. Okay, users can generate a report to show several attributes of their yard: sustainability, edibility, how many edible plants are in the yard, are they native. This report can be used to help sell the positive attributes of a house. So think about putting your house up for sale and you kind of give the buyer or potential buyer a manifest of the plants that are in your yard. Now, team members, you see for this it's just going to be me, but for you it is necessary to work in groups of 3. That way we'll really understand the value of GitHub and how it can be used to foster group dynamics, and also why interfaces are important. Okay, storyboard. There's several good storyboard tools. One of them is called Fluid UI. And that, I have a video, again, I'll put this video, I recorded it for a different class, but it's still perfectly valid for our class. So I'm just going to put it down kind of in an additional reading section. So not required, but if you want to understand Fluid UI a little bit more, it's a video that will walk you through Fluid UI. Fluid UI I've used for quite a while to do storyboarding. It's become a bit more commercial. It used to be really easy to go in and create create a storyboard for your application. And this is what I mean by storyboard, something where we can kind of see all of the different screens and we can get an understanding of what it's going to look like when it runs. So you see this again was something for a mobile class. You see it popped up to a main menu, which is something I said I typically don't recommend those because it's an additional click. And frankly, it's confusing to the user. A lot of this could be consolidated on one screen anyway, but nonetheless, you see we can click through and we can take a look at this shopping list and shopping list items. Delete shopping lists, search recipes, all of this. So you see it kind of lets us look at what the app can do, and it gives us a good mock-up so we can get some user feedback on the app before actually investing any time in it. So Fluid UI, great tool for this, outstanding tool. The only trick is it has become a bit more commercial. I have a legacy account. I don't know if you sign up for a new account, you might get a few days free or a couple projects free, but really that is all we need for our use is something like that. It is self-explanatory once you get in and you edit these screens because it has all the widgets you would want. You simply drag them over and it's fairly easy to put together. If you're not a fan of Fluid UI, and I looked for several others, there's several other options as well. What you can also do is just use Visio, which we take advantage of our MSDN AA account with UC. And Visio, if you say, I want to do a new diagram, you can search for wireframe. And it will take just a moment, but you come up with wireframe design like this, then hit create, and it's essentially what I did on a different screen. But if you take a look at controls here, you have a lot of the controls that you would see on a typical web page. So drop down, hyperlinks, stuff like that, and you can start to put together a page. So with that, I put together a couple of pages. We'll go back to this, whoops, cancel out here, and we'll go back. I just did a quick and dirty on a couple of pages that I would do for my plant diary. So remember, the home screen, we want to jump right into the action. So here we go with my plant diary, and you can see we have kind of a map of these are plants that are already in your yard. Select a plant to view details. So in other words, click on one of these GPS icons, and then it will take you here to this detail page. And you can do things like you can edit when the date was planted, who it was planted by, and then you can add notes, and the idea is you can add notes over time. So the first year it went to fruit, how bountiful was the crop, do we need to spray this one for fungus and things like that. So what kind of notes have we taken for this plant over time? So I took those in Visio and I just ran over and I put them into this storyboard section with a little label, maybe a couple notes on how the user would interact with that page. So give us a look and feel. Are we putting too much clutter on the screen? Those are the things that we're going to look for on these storyboard screens. Do we have too many screens? So if you have multiple screens, just label them and indicate how the user would navigate from one to the other. Or if you're using Fluid UI, you can just provide a link to your Fluid UI storyboard, and then I can just click through, as I showed you in that demo just a little bit earlier, and I can kind of get a feel for how your storyboard is going to work. Okay, we move on down to functional requirements. Now take a look at this. As a homeowner, I want to be able to catalog my plants so that I will remember what I planted. This matches this functional requirement definition that I have here, so fill in the square brackets with your own words. This is a common way that we will elaborate requirements in industry today. As a user, I want a feature so that I can do something. Now, that is a language that anybody on our project can understand. It's called a ubiquitous language, and this is part of behavior-driven design. The idea is that we state requirements in this ubiquitous language. Then we sit around and think of examples and given when then syntax. By we, I mean software developers, QA, business analysts, project managers, all stakeholders. Anyone with anything involved is going to sit here and is going to elaborate through a series of examples. So, why is it important that everybody think of examples? Because we always tend to think happy path. And when we think of examples, we tend to think of happy path and other scenarios that we need to cover as well. So, as a homeowner, I want to be able to catalog my plants so that I will remember what plants I planted. Given the user is logged into my plant diary, when the user searches for an eastern redbud, when the user adds text details about the eastern redbud, then the user's eastern redbud will be saved. So that's one set of given when then examples. Let's take a look at another. Given the user is logged into My Plant Diary, when the user searches for just some garbage text, then My Plant Diary will not return any results and the user will not be able to save the plant. So you see two different scenarios here I've elaborated in given when then syntax. Now if you look at this given when then syntax, you can probably think about how that would make for a very good unit test, specifically a test-driven design unit test or a behavior-driven design unit test. So when we are meeting with the business analyst and all the other stakeholders, we will come up with this essentially requirement, and then we'll come up with a list of examples and we'll say, okay, if the software that I write executes each of these given when then examples as we've specified, will we consider that software meeting the requirements? And then everybody around the table says yes, and then our job is very clear. So this is essentially a feature, and remember this feature because that's going to come back in just a moment. Now next one, as a homeowner, I want to be able to upload photos of my plant at any time. And then we have three given when thens here. Given the user is logged in and has selected a previously saved Eastern Redbud, when the user uploads a 640 by 480 photo, then the photo will be saved to the specimen profile and can be viewed later. So that's essentially a happy path. Given the user is logged in and has selected a previously saved Eastern Redbud, when the user uploads a 100 gigabyte photo, then the photo will be rejected as too large. So see, here we have a case where the user has uploaded an invalid photo, and this is not a happy path scenario, but you see we're going to handle this in our testing, which means we're going to handle it when we build out the application as well. Given the user is logged in and has selected a previously saved Eastern Redbud, when the user uploads a 600 by 1200 photo, then the photo will be resized automatically, then the resized photo will be shown to the user. So this isn't necessarily an edge case, but it is a case that requires some additional processing, and something again that we'll consider this semester. As a homeowner, I want to generate a report of the sustainability of my yard. Given the user has a valid account and specimens associated to that account, when the user runs a report, then the user will see a report of plants, dates, native, edible, and sustainability rating. So again, a happy path scenario. Given the user has a valid account and no specimens associated to that account, when the user runs a report, then the user will see an error indicating no data available. So you see, by elaborating through these examples, we get a really good grasp of all the things we're going to need to cover. Because when we tend to estimate things, we tend to only think happy path. We don't tend to think what happens when these things fall over. But more importantly, our given when thens will quickly turn into a set of behavior-driven design, test-driven design unit tests. So that's the analysis phase. And I think you'd agree with me that anybody of any technical level, at least anybody familiar with the language in which this is written, is going to be able to read this. So this isn't a developer-only kind of system. Now we move down to the class diagram. For class diagram, I really like Argo UML, and again, I will put some reference videos for Argo UML in this learning module. This is a diagram that I have started in Argo UML. To get to Argo UML, I'll add a link to the learning module, but it's argouml.tigris.org. And one interesting thing about Argo is I've used this almost my entire time at UC. So this is going back to about 2000, 2001. This is one piece of software that's actually changed very little, which is nice because I can use it over and over again. It still works. So a couple important things. We want to make sure that we are considering all layers of our application. As a microservice application or an enterprise application, layers are very important. So you see this little kind of envelope thing that indicates a package, and we can drag and drop this down, and then we can put a class inside of that package. A little tricky here. We just have to drag. Whoops! Looks like I put them together. So you see, you kind of have to drag the class into the package, and then they move around as one unit. But then you can click on the top of this, and you can give the class a name, my class. And I'm going to remove this because I've already done all my packages. Up in the top tab here, we want to give it a domain name in reverse. So package name, com.myplantdiary.foo. So that's essentially how we put together one of these packages. As I mentioned, I've already put mine together over to the left, to the right. So just a couple things I want to call out. In your class diagram, I should see one package for DTO. DTO is the traditional noun class. So for us, it's a specimen. A specimen is a plant that I've put in my yard. It could also be an event, like the specimen went to bloom or the specimen went to fruit. It could also be a photo. So these are different DTOs. These are data transfer objects. Think just nouns. Think of things that have attributes, and that's what we have here. Now underneath that we have the user interface package. This is where we put the classes that are going to be handling button clicks and other things like that. Also the controller that we've already made. There might be one to handle the map of specimens where we show all of the specimens the user has already saved. Add a specimen if I add a new plant to my yard. And add a photo maybe if I want to catalog this plant over time. So these are just the user interface classes that are handling interaction with the user. Now if we take a look to the right, we should have a couple of other packages as well. A service package is where we do business logic. This is like where we're computing promotions. If it's buy one get one free and I've purchased 7, which ones are free? So doing that kind of logic where we're actually making decisions on how are we going to implement these rules. We should also have one called DAO for data access. And so data access is really just doing the very fundamental CRUD operations against some data store. Could be a SQL-based database, could be a NoSQL database, could be a downstream web service, or anything else. So in your class diagram, I anticipate seeing all 4 of these packages. Careful here. Sometimes I see a class diagram and the group has only sketched out the DTOs, not these screens that are doing logic. So these DTOs, again, are just nouns. These logic screens are doing things like handling events for the UI, then business logic for the service layer, and then persistence logic for the DAO. So be sure to segment these into packages. The DTO, these are classes that are typically either method return types or method parameters. So many times a DTO is kind of an independent class that floats across each of these layers to transfer data, hence the name data transfer object. So one other thing that I will point out, remember the value of polymorphism and remember the value of spring. Spring means that we can declare a variable and an object will be assigned to that variable at a later time. But what's more important is the object type and the variable type might be different types. So anticipate this. What I'd like you to do in the service and the DAO layers, the very first thing I want you to do is make an interface. Not a user interface, but an interface is in the Java construction interface. Remember with polymorphism, variable type only needs to be a list of methods. So this interface will serve as your variable type. Just think of the methods that you want to expose from the service layer to the UI layer, or from the DAO layer to the service layer, and that's what you should put in that interface. Now the trick is we're not going to get into persistence for several learning modules, but we don't want to hold up the user interface until we've gotten to that point. So again, for the person doing service and DAO, I'm going to ask you to start by defining this interface. After you've defined the interface, come up with a stub. A stub is just a hard-coded mockup. That's it. You're not actually saving anything. You're just giving a hard-coded mockup so that Spring can marry this hard-coded mockup into variables of this interface type, and then the person doing UI or the person in the next layer can program against that interface in a predictable manner. While the UI person is programming against that interface, the service person can actually start working on the actual DAO, the actual implementation, without being worried about holding up the person doing the UI. And again, the person doing the DAO can do the interface, mock out a stub, just a quick and dirty hard-coded stub, provide that to the person doing the service, and then the person doing DAO can work on the actual implementation and have the flexibility of taking a bit more time without worrying about impacting all of these upstream parts. So, inside of the packages, I would like to see an interface, a stub, and an actual implementation class. One other note is that you'll notice that an interface in Argo has 2 boxes. The kind of dash, the less than, greater than, and the word interface. The reason why it only has 2 boxes is an interface is essentially just a list of method signatures, so it doesn't have attributes, where a class will have attributes. Okay, so note the dashed line here. Dashed line indicates this class implements this interface. So if I were to create, let's go down here to myPlantDAO. If I were to create a new, we'll give ourselves a little bit more room here, and scroll this guy up, there we go. So let's say I were to make a new interface like so. I'd call this one iEventDAO, like so. And then note when I click on it, you see the little dashed line guy that comes out from here. I can click there, and I can say EventDAO stub, which is the first thing I would work on. And then I can click one more time, and I can say EventDAO. Just like so. Notice that both of them have the dashed line with the capped arrow, which indicates a class that is implementing an interface. Now what about extension? We'll take this controller, move it over to the side a little bit because that controller we've already created, that's our Spring Boot controller. Let's say that we want a superclass of all of these 3 screens here. What I might do is just click that little up arrow, which indicates that this class extends from another class, and we might call this myPlantDiary screen. So maybe that's all the overhead information that's common to each of these screens. Then I simply drag on the capped arrow here, and I drag it to all of the subclasses, and now I've set up the superclass-subclass relationship. Probably ought to get that line. It's not good to have the lines crossed, so I'll move them around just a little bit. But notice the difference here. Solid line with the capped arrow indicates a superclass here and a subclass here. Dashed line with the capped arrow indicates interface here and implementing class here. One more thing, any class that has a dependency on another class will use a solid line to indicate that. So note I click on Map of Specimens, that will likely have a reference to Specimen Dao. So I just grab the line and try and drag it, and there we go, looks like we got a connection. Add specimen, going to be the same thing, and add a photo, going to be the same thing. They're all going to have a dependency on this iSpecimen Dao. Now note that I've tied those to the interface, not to the implementing class, and there again that's very important, especially in the land of Spring, because we know the only hard-coded dependency we're going to have is on the variable type, which should be the interface. The object type can be changed by Spring at time of need. So I scroll to the right here, let's do a couple more. Let's take a look at Specimen Dao. Note that the hard-coded stub is essentially independent and is not going to have any dependencies. But the Specimen Dao, the actual implementation, is going to need to reach down and make some kind of connection with EventDAO, with Specimen Dao, and with Photo Dao. So it's going to need a connection to each of those. And there we go. Okay, well, one more try there. And I think we have magic. There we go. So now I'm satisfied with my class diagram. And what I can do is, first of all, I can save it, but then I can also export the graphics. And we'll simply save them here to the UC directory as my plant diary. Now I'm going to add that to my class diagram document here, my design document here. So I'll say insert, and then we're going to say picture. And then I'll navigate to my UC drive and grab plant class diagram, and there we go. So you see that diagram I did in Argo UML, it sits in here. Now under the description, I just verbally described all of these to you in that last video, so I won't bother to type it out, but I will ask you to go ahead and just give 1 or 2 lines for each of these classes. Don't worry about big paragraphs, just what's the purpose of each of these classes. Okay, just a couple more things to go then. Scrummy. I'll put together my Scrum board in a separate video, and I know I introduced it a little bit in the Scrum video, but to create a Scrummy board is simple. We just pop out to a browser and say scrummy.com, scrummy.com, and then slash, and then we give a name for our project. So I might say my plant diary, just like so. And give it just a moment to think here, and there's our Scrummy board. So now what are our stories? Stories are features, they're not technical tasks. Now you might have a story, and let me try and grab here. Okay, you might have a story that's something like environment setup, but that's really as technical as you want to get. Most of these are going to be features. Now, where are we going to find those features? Well, remember our design document. Remember those three, as a homeowner, I want to be able to catalog my plants. So catalog my plants would be a feature. Upload photos of my plants would be a feature. Get a report of sustainability would be a feature. So I can click into here, say new story, and we'll say catalog my plants is a story. And remember that matches up with our document. Okay, so add a photo to specimen. I'm going to call them specimens here actually. So let's say catalog my specimens. Change, there we go. Catalog my specimens. And then we'll say check, there we go. And then we'll say get a specimen report. So we'll leave that there as stories for now. We're going to need to add tasks as well. We'll come back and do that in a separate video, but for the moment, I at least have a Scrummy link. So I can take this link and I can add it to my design doc, and that's all I'm asking you for here is the Scrummy link. So boom, then I'll go out and I'll take a look at that. Roles, what I'd like you to have here is who's the Github admin. So Github admin and then product owner, Scrum Master, that's going to be me for this project. Then we'll have UI, that will be me as well. But in your project, these should be different people. Services and persistence is going to be me. What's interesting is I can tell you from my own full-time employment, this kind of division of labor is actually fairly typical. It could be an individual on each of these. It could even be separate teams of people doing each of these. So division of labor, very important. Finally, the GitHub project link. I have a separate video where I did our GitHub. And so I'm going to just navigate out here and go to github.com. And I'm going to grab repositories. I'm going to grab the GitHub link, copy, there we go, that I created in that separate video. And boom, just paste it there, and we're all good. So we still need to fill out some tasks on the Scrummy board. We also should add some class diagram description, but aside from that, this is essentially what that design document should look like. So I'm looking forward to reading your designs, and more importantly, I'm looking forward to giving you good, quality, and timely feedback to make sure you're making the most of your time this semester. Thank you.